Hello, I am Dr. Ravi Chandra. I have done my engineering in SJC Mysore and MTech from SJC Mysore, and have done my PhD in Auckland University of Technology, New Zealand. I am here since 2018 and I am HOD of Department of ECE MIT Mysore. I welcome you to Department of ECE MIT Mysore. So, we have 5 PhDs in the department and we have lot of R&D going on in the department, and this is HOD's office, and the vision and mission of the department are disseminated in the office. And the department was started in 2007 and the intake was increased in 2010, and we have come along a long way and have achieved a lot. So, this is the area from where we operate, that is HOD's office, from where everything is controlled, and we have a bit of reading journals for the faculty. Whoever come along, they come here and read through during their free time, and we have a department PC wherein all the data is stored and pretty much everything is disseminated from here. She is Mrs. Chandrika, department DEO assistant, and takes care of all the documentation of the department. These are various accolades and achievements of the department, trophies and various sports activities of the department, and these are the files from where everything is controlled and the data is collected into. So, we have staff list displayed on this wall of the HOD's office, and student details are also put across for a quick reference to all the people who come, and we have some guest chairs as well. Okay, let us go to other parts of the department. Display, wherein all the videos and various achievements and current technology trends are displayed. We have a fire extinguisher in this corridor, and we have various eminent personalities displayed so that the students get motivated with this ambience on both sides of the corridor. S. Radhakrishnan and Abdul Kalam. So, we have staff rooms, spacious staff rooms with cubicles for the staff. This is the staff room, and vision and mission of the department are disseminated in the staff room as well. This is Professor Maria Pavitra, this is Professor Priya MS, there is Mrs. Anisha PS, this is Mrs. Lavanya M, and we have Dr. Shanti Ajish, one of our senior faculty of department. We have various categories of notices put across. So, one for IA examination and one for department association and professional bodies notice boards for students to make use of the notice board facility so that they can put across their achievement through the department. This is ECE Lab 3, which acts as communication lab for this semester. So, in the lab we have various displays put which give necessary message to the students like save power, and we have on the notice board we have layout of the lab put across, and we have students list, equipment list, and any health related message. We do ask them to follow disciplinary and safety rules all the time. The vision and mission of the department are displayed across for the students to always keep remembering about the vision and mission of the institute and the department. We write course outcomes on the note board, and we have written the subject code of the laboratory, communication laboratory. We have some posters put up which give additional knowledge to the students for a quick reference of the equipment and components they are using. There are some PCs put across in the lab for simulation experiments and any software related experiments in the communication laboratory. So, this is Professor Siddharna Janai. So, he is laboratory in charge for communications lab. So, let us hear more from him on one of the experiments.
Thank you, sir. This is Siddharna Janai, Assistant Professor and Lab in charge for Communication Lab. In this particular lab, we are going to conduct communication experiments, say analog communication experiments, digital communication experiments, microwave signals and devices experiments, and microwave antennas experiments. Now, coming to the hardware part of the experiments, we have analog communication experiment and digital communication experiments and microwave signals, whereas in simulation experiment, that is software experiments, we only have the digital communication part of it. So let me go through the circuits what we simulate here. This is actually a MATLAB Simulink model. As you can see, this is the input waveform which we are XORing for DPSK, and the output what we can compare is a DPSK wave with the message signal. And similarly, we are demodulating it over here, and this signal is a delayed version. As you can see, this is similar to this one, but there is a delay in between input and output. Similarly, we have a pulse code modulation experiment over here. In this experiment, we are going to simulate a message signal which is having a low frequency converted into a high frequency bit stream, and we are going to demodulate it. And as you can see, there is a delay in between input and output, but what you can observe is the frequency and amplitude are almost same. So that is about the simulation experiments. When it comes to the other experiments, say the analog modulation, which is basically what we are doing is amplitude modulation over here. If you change the amplitude of the message signal, the carrier's amplitude is going to vary, that is instantaneously it is going to vary.
Thank you, Professor. So we have do's and don'ts put across for the students to do and don't in the laboratory. So we try to guide them all through the lab experiments and give them sufficient ethics as well as morality and code of conduct as well. So we have, as said, we have various posters put up which give additional knowledge to the students and additional information, various experimental setup, various equipment of the lab. So please come along. We have a reading corner as well, which is an important part or an informal part of the department, wherein several books are kept and everyone is free to come and spend their time during their free time or break time and read here. One of the dedicated instructors is around, and if anyone wishes to have any reading to be done, they do come and approach that instructor, and that is given to them, and they spend their time reading through it and discussing. So this is one informal part of the department. So these are all the equipment which are used in various semesters, various courses. This is Texas Instruments Innovation Lab, so which pretty much has all the equipment which is a part of university program of Texas Instruments and helps us to do various out of the syllabus experiments. So this is Professor Maria Pavitra, in charge of the lab, and this is the notice board wherein all the details of the lab are displayed. Again, vision and mission dissemination. And here we have Texas Instruments related posters put up, wherein the details of the Texas Instruments kit board like metering applications, security applications, all the details about the metering applications, etc. are put across. And here we have microcontroller boards which are used during microcontroller subject and practical course. 8051, that is Atmel controller, 89C512 are used, and we use various equipment necessary for various hardware and software interface through the lab. So an experiment is being run there. Students make use of this lab for various purposes, including their mini projects. And the Texas Instrument boards, this is Professor Anisha PS, whom we met in the staff room. She is in charge of DSP lab and Texas Instruments Innovation Lab, Madam, can you please explain this particular board, what it does?
So Texas Instrument via Educate have sponsored few kits for us. We have 3 different kits, and here we have used ASK Pro Starter Kit. With we have used this to execute a simple output for non-inverting amplifier, and the result is as shown. So this can be used by students whenever needed for mini projects or the purpose of main project also, for their mini projects and main projects. Thank you.
Along with this, we have the safety measures in the lab, that a first aid kit, and then the whiteboard. We have the UPS also, which is having a 20 kVA capability, and along with that we have LAN facilities, and we have displayed the etiquettes of the lab that we expect the student to behave when they are in this lab space, and lab etiquettes. And then we have also displayed the equipments along with their specifications and the number of equipments that we are using in this lab space, as well as we have the batches that the students will be occupying the lab for the particular event. Now for in case of the odd semesters, digital signal processing lab will be running in this lab space, and in case of even semesters, microcontroller lab will be running in this lab space, and whenever the students are free and interested students will come and do the projects or the experiments based on the TI instruments provided. And during the pandemic times, we have some disciplinary measures that we have taken, and that is also being displayed here. Along with this, we have 28 PCs that are available here, and the different interfacing kits. So as we have seen already, the microcontroller interfacing kits as well as the DSP kits, and then we have shown the experiment there, which we are dealing with the interfacing of microcontroller along with the digital to analog converter.
So we have another staff room here. This is a bit larger one and has got some additional facilities as well. So this is Ms. Suma R. This is Mrs. Renuka, Mrs. Saumeshri, Mrs. Anita Raghavendra, Mrs. Manasa, Mrs. Veena SK, and Dr. Smita Joyce. So here we have some additional facility for the faculty, a common desktop and printer. Along with that, we have microwave as well, so wherein the faculty can have hot lunch and breakfast. In the ground floor, we have classrooms and a few other labs. So one of the classrooms with a total area of 65 square meters and ICT enabled. So we have classroom here with vision and mission of the department disseminated for the students for a quick reference, and the benches, and we have ICT enabled projector with LAN facility for the students, and good air and ventilation is available. We have CCTV facility as well for security purposes. So this is the electronics corridor, what we can say, fully occupied with electronics, classrooms, laboratory and staff room. So we have ECE Lab 1, our premier lab, what we can say, with sufficient floor space and sufficient equipment. So we have facility for students to put up their bags, their records, their any additional material they bring in. So for them we have pigeonholes. The power supplies are kept, which will be borrowed by the students when they are doing the experiment. Various resistance boxes, capacitance boxes. So various kits wherein we have temperature trainer kit, Kelvin bridge trainer kit, and we have pulse modulation, Wheatstone bridge, all the modules for various lab courses, practical hands-on courses, and we have sufficiently spaced equipment for students to do their practical courses on electronics, power electronics, electronics and instrumentation, embedded systems, all are engaged here. So here as well we have posters for various students, and in this lab we have the fire extinguisher since this lab has high power and has an UPS facility, so there is a chance of fire hazard. So we have made sure that there is a fire extinguisher in the lab as well. So there are various experiments which are being run during both the semesters in this particular lab. So we have Professor Devendran here, who is laboratory in charge of this particular semester course, analog circuits, and we have Professor Lavanya M, whom we met in staff room. So they run the courses here, practical courses on analog circuits. Can you please explain about the lab once?
Thank you, sir. So the first thing, when we enter into the laboratory, this is the first thing we look into it, and this is the notice board where we have displayed the lab layout and the subject timetable, batch list, and the list of experiments we are going to conduct in this particular laboratory. And we have signboards to remind the students about the ethical values and the PO number 6, engineer and societal needs. And we have disseminated vision and mission of the department as well as institute, PEOs and PSOs of the department here. And we have sufficient number of the desks where the experiments are going to conduct by the students. We have 16 such desks. The beauty of this particular laboratory is we have fabricated the n number of analog circuits devices into a single cabin. This is the beauty of this laboratory. See, when we looking into this particular cabin, we have variable power supply of the specification of 0 to 30 volts. 0 to 30 volts, and signal generator is having the frequency of 0 to 3 megahertz capability, and we have a CRO which is having the capability of 0 to 30 megahertz displaying capability, and we have instrumentation cluster where the DC ammeters and voltmeters and AC ammeters and voltmeter facility here. And when coming to the layouts, students are facilitated with simpler adjustments here. See, by looking at the color coding of these knobs, they can easily rig up the circuits. This is the beauty of this particular laboratory, and the computer system is provided to perform the simulation experiments for the students. In this particular semester, the course which we are running in this laboratory is Analog Circuits Laboratory 18 ECL 48 for the 4th semester students. The POs which we are addressing in this particular laboratory are PO 1, 2, 3, 4, 5, 9, 10 and 12. PO1, apply the engineering knowledge. PO2, analysis of the engineering problem statement. PO3, design of the electronic components. PO4, lab equipments and its usages. PO5, modern tool usages. PO9, group and individual work that students are going to conduct, and PO10 talks about the communication, oral communication and written communication. PO12 is about the lifelong learning. Along with those POs, in this particular laboratory, we are addressing PSO1 and PSO2, program specific outcome 1 and 2, by using the following course outcomes. These are the 4 course outcomes we have written in this for this particular laboratory. And coming to the safety measures, what we have taken for our students are, so they need to follow the do's and don'ts very strictly, and we have first aid kit for them, and we have displayed the charts for them. Since this is an analog circuits laboratory, the biasing part is very, very important. So transistor biasing procedures have been displayed in the lab so that the students can have a quick look at that, and they can easily conduct the experiments by looking at the chart for the reference of biasing the circuits of various configurations, and to look at the input and output characteristics of the circuit.
So this is electrical lab, that is ECE lab 6, wherein all the first semester students and second semester students engage in doing basic electrical engineering laboratory course. So here we have all the equipment set up. So 3-phase as well as single-phase equipment are available here, wherein the students would be engaged to learn both the type of electrical power supply, both the type of experiments. And this is Dr. Shanti Ajish, with whom we met in the staff room, and she is one of the lab in charges for this course. Madam, if you can explain further on this.
Hello, sir. So this lab is actually caters for the first and second semester students. So the lab space is used for the whole throughout the year, and the experiments are like the students will get an insight about the day-to-day application of electrical energy, basically at the domestic end. So we have experiments both on single phase as well as three phase, and even DC power supply experiments are there. The lab is set up with very good safety measures, such as we have a very good earthing here, and all the kits has circuit breakers and all. So we assure the safety of the students here, and to have some AC and three-phase systems are on the kit, but to have an exposure how to rig up the circuit and how to connect the meters and all, we have a first experiment which is verification of KVL, shows voltage law. We are using a breadboard as well as the discrete components, so that they get an exposure to how to connect different components on a breadboard, as well as how to connect a voltmeter, ammeter and all. They get the idea. So that is how the lab is set up, and for all the experiments we have two kits here, so that the batch of 25 when come, they can easily do the and get an hands-on exposure to all the experiments. So we have the POs which are covered under this course is actually PO 9, 10, PO 10, PUSO 1, etc., in which we have the course outcomes which will supplement the attainment of PO there. So as it is shown, so by doing this experiment, the students after this course will have an idea how to use the basic instruments such as multimeter, ammeter, wattmeter in a circuit and measure the electrical parameters. And then by that they apply how the Kirchhoff's voltage law or current law can be applied in a circuit, so that to prove or verify the laws there, so that they have. And the thirdly what they attain is they work in a team or individually, and they will be able to orally communicate the details of the experiment. At the same time, they document it as the record. So we have a evaluation process, like the program starts with, we have the manual here. So this will be distributed at the start of the semester, so that students go through that and get the idea how to perform each and every experiment. And then we have a workbook. This is for the continuous evaluation, in which the student is supposed to write the details of each and every experiment. This is the first experiment, like, so they have to write what is the circuit diagram, what are the procedure, and the details of things. Even a bit of the theory also we want them to refer. Like for the case of three-phase, they write the phasor diagram and they prove that the relation between voltage and all. So this is for continuous evaluation. Every day we evaluate the experiment, the performance according to the COs. So that all the COs details are entered here, and at the last, after the experiments, we take the average of that with the internal test mark. So that's all about the evaluation process we follow here. Then of course the details of the labs are showcased in the notice board. I think that's the thing, sir. Thank you, sir.
So we also have a first aid box in this lab. So pretty much all the labs have first aid box for any exigencies happening, accidents happening, and we have some demo units which are out of the syllabus. That is not mandatory experiments to be done by the students, but we have cross-sectional demo units wherein they can see the inside of a machine and know various parts of the machine, and they can realize, okay, this is how an actual machine is built or designed. So we have MCB and fuse unit as well. Protective devices which are used and demonstrated.
So cutout sections actually supplement the theory which they learn, in which we speak about the constructional details, so they will become more clear. So for a better understanding, we have the cutout sections.
Okay, moving on, we will be moving to the next lab, so which is adjacent to this lab. So we have digital system design lab, wherein various digital systems are designed or concepts of digital systems are realized by the students in their third semester. So, this is Professor Shivprasad K, who is in charge of this lab, and this is Mrs. Purna Chandana, who is technically in charge of the lab. They handle the lab, and these are the kits. Can you, sir, please explain more about the kits?
So this is the ECE lab space 2. So here we will conduct a digital system design lab, okay, for the third semesters. And the main equipments in this lab are the IC trainer kits. Okay, we have 27 numbers IC trainer kits, and here we have the one IC trainer, IC tester, and we have the one IC tester kit. Okay, and this is the space where the students will collect the components from the instructor. And we have a 6 working benches where the students will going to work, and the one faculty table is there.
So, we have various charts put across to give them more details about different components which they will be using and the way in which they need to interface in the pin diagram. So, we have logic design charts prepared by the students themselves. So, and various
Charts has been displayed to give the information about this lab equipments, and we have 4 PCs. Okay. And this totally this experiment, digital system design lab experiments containing 12 experiments. In that 2 experiments will be having the simulations. The rest of the experiments will be conducted by using the trainer kits only. So we have 6 experiments related to the combinational circuits, and the 4 experiments related to the sequential circuits. All the experiments will be implemented by using this trainer kit only. And even we disseminated the vision of the institution and the department in the notice board. And we have a notice board
for the lab dedicated, which tells all the details regarding the lab syllabus, lab batches,
timetable, and the batch list will be displayed in the notice board.
This is Professor Guru Prasad. This is Dr. Balakrishna. So, we have sufficient cubicle space here, and we have attached bath toilet for this staff room. So, and each faculty is provided with a small white marker board so that they can write their day-to-day activities and schedule so that they don't forget during the day. And this is another staff room with sufficient air and light. So, this is Professor Sandesh. So, and we have office etiquettes displayed in all the staff rooms, wherein the etiquettes of the behavior are to be followed. And this is Professor Rajesh N. This is Professor Lathan MM. This is Professor Ravi Kumar. So, all our staff members of the department and share the staff room. We have attached bath and toilet for this staff room. We can go further. And in the corridor and stairs, we have vision and mission of the institute along with all the POs disseminated as well. So, this gives the students an outlook on regularly on what they are actually for in the institute and what exactly they need to do. So, going further, we have MOUs with various industries and various companies, wherein they give us their expert knowledge, their inputs regarding various points which are to be incorporated into the curriculum. So, we have MOUs with Government Tool and Training Center, Avaya People's Network, and DHS Informatics, Intrela for various purposes. They interact with us, they take our students for internship, they do contribute to the learning of the students. So, we have one more lab and additional lab facility in the department, which we will go through. This lab space, this is Professor Mahadesh KM, so who is in charge of the lab, and this is ARM lab and as well as VHDL labs. These are various kits which are displayed. This is one of the spacious labs in the department with more than 50 systems. We have vision and mission disseminated, the course outcomes of the lab as well as the lab title, various kits used. So, Professor Mahadesh, can you please explain more about the lab?
Welcome, sir. This is ECL 5. We have a total area of 124.5 square meter consisting of teaching area, a practice area and those 2 utility rooms occupying an area of 23 square meters. We have a 20 kVA UPS to support these systems in case of power cuts. We also have a separate area which can be utilized by both faculty and students to carry out some projects. Moving on to the facilities available in this lab. We have 54 computers. Those computers are installed with OS or Windows 7 64-bit to support various softwares like
You can cut it off. You can put it on silent.
we have various softwares like Xilinx Vivado for VLSI and HDL. We have 2 servers for Cadence as well as MATLAB. Then we have the Fields 4 software to run ARM or Embedded Controller Lab. This lab will be utilized for running VLSI and HDL lab during the odd semester, and now in the even semester we will be running Embedded Controller Lab. So we have various FPGA kits through which students can emulate their HDL design consisting of Spartan, Xilinx Spartan FPGA. We also have a Basis 3 which consists of Xilinx Altrix FPGA here with all the push button switches, the 7-segment display. Then we have the various actuators like stepper motor, DC motors which can be interfaced with these kits, and students can emulate their design onto this FPGA and control these devices.
This is project and self-design lab. So, wherein we have various activities being done in the lab being displayed on the notice board along with the layout plan, and these are various facilities available along with workbench, power supplies, soldering station, systems for the students to come and sit whenever they are free and do the mini projects or projects and keep working on that. This is a sort of work area which inspires students to do more than their curriculum and keep executing projects, their designs, their ideas. We motivate students to do more so that our outcomes are better and hence contributing extensively to outcome based education and realizing all the POs and their attainments to the best possible levels. So, this is a recent project which is being done by one set of students, that is converting an old bicycle into an electric cycle, where they have interfaced or modified the front wheel driven along with the facility for back wheel pedaling. So, where they have attached a self start motor, a used self start motor, everything here is reused, recycled, and they are able to give additional support while pedaling for the rider to go across high terrain and etc. These are various products developed by the department faculty, a DC to DC converter for total station of civil department, and this is Vispro sensor which is developed for PhD project on precision farming which was funded by Government of Karnataka. These are various charts for students to go through and learn more, and these are some of the students who are currently working on their projects. Ganesh, would you like to talk? He is our 6th semester student. Would you want to talk about the self-design lab, project lab?
Sure. There's a very nice thing that we have a self-design lab in our department. Basically, the students really need this kind of a lab because when we have interest to create something, these kind of labs will help us. So here are some projects that our seniors and our juniors have done. And presently we are working on some models. Yeah, sure.
Yep, that's great, Ganesh. What I understand from this is the robot moves when your inclination moves towards a specific direction,
Yes,
isn't
we
it?
have used a blink app
Okay,
to control this board.
good.
There we have accelerometer where depending on the axis the robot can be moved. And there are many such automations we have done. We have done software projects also. And here is one project where we have done home automation for specially abled, where we can control the lights and the fans through our phone.
One of the very active labs in the department wherein students spend quite a amount of time and conduct various activities, various projects, various workshops. This is Professor Lokesh BS, who is in charge of the lab and who has been guiding students to do various projects, and it's been going well. So this is all from Department of Electronics and Communication Engineering, MIT Mysore. So we have been touring all the department facilities, and I believe you have quite an overview of what the department has got as facilities, and the core strength of the department is the faculty. We have 5 PhDs with 1 international, 2 state and 3 state and 1 national level university PhD with wide range of exposure to various research and academic processes. So we are in the verge of taking up consultancy and product based development of the research. The research groups are categorized and we are planning to take it further. That's all from Electronics and Communication Engineering. Thank you. Have a good day.